Sometimes the software could design things that are unpracticable, and other times it could also go around the route of designing something that is just absolutely technically wrong. And this is why you need to also have a knowledge of structural analysis and structural design before you use this software. It's only meant to guide you, it's not meant to teach you. You need to be a professional in the field of structural engineering to be able to use this software and maximize the advantages that it offers. Now, we have designed a part foundation. However, there are some things I would like to show you for you to know that the software itself is not enough to design accurately and economically. So let's try to go into our foundations. Let me go to something like this footing, which is 1.9 by 1.9. I can see when we go to the Rebar here, it says 14 quantity and 13 quantity. I don't need this. I don't need this. So now what I want to do is I can go back to the geometry, and then you see this is 1900 by 1900. The Rebar says 14 quantity on the x-axis and 13 quantity on the y-axis. Now if I use my calculator to divide 1900 by 14, see that we are getting 135. And what does this mean? This means that it's not really possible for you to arrange 14 bars on a 1900 long or wide base, and that's because 1900 is quite small compared to the spacing that is required, which is 150, and also the cover that we are going to be removing, because when you go here now you see that the cover is 40 mm, which means you have to remove 40 here, you have to remove 40 here, you have to remove 40 here, you have to remove 40 here. And when you remove 40 here, that means you are even having 1900 minus 80, which is going to be 1820. And when you have 1820, it means that the highest you can have in 1820, that's divided by 150, which is your spacing, is 12. Whereas it's telling us that we should use 14. It doesn't make any sense. So what you can do here now is change this to 200. Change this to 200. It gives us 11. Then you can change this also to 200, and you see that it gives us 11. So, and when you look at it, what we need is actually, we are looking at using 12, but at least we have 11. So you can also use 175 here, and when you use 175, see that it is 12. Then you can go here and choose 175, and see that it is 12. And you can see that our design here is still very successful. And when you go and press OK, you realize that your design is still very successful. So these are things that you need to be able to do on your own, else you'll be creating a very impracticable design. And when you go back to it and you check your rebars, you see that you have 12 here, 12 by 12, and then on the x axis, and 12 by 12 on the y axis. And this isn't just only economical, it's also practicable. And this is something that the software will not do for you, something that you have to learn how to do for yourself, sometimes through experience and other times it's through your professional background. And when you go to your design status, you see that it's okay. Let's go to our review and let's go to our 3D, which shows design status. Everything is still okay here, despite the fact that we reduced some of our spacing for the reinforcement. And now you can also go back to your 2D model, and you can also check the entirety of the columns. Let's go to properties, and you can see that everything is marked okay here too. So you can check this 1.5 out to know exactly what is going on here. And you can see that with this 1.5, it's giving us, this is just another example. So you see that with 1.5, it's giving us 11y12 on the y-x direction and 11y12 on the y direction. I don't need that. You can always do that. For this particular project, we don't need that. So, and you can see that when you go to your calculator now, so you can okay this or cancel. When you go to your calculator, you see that 1500 divided by 11 gives you something funny. That's 136, which means there's no way a 1500 by 1500 column base can accommodate 11 y12. It's not possible. And now you need to modify this, and you can go on to your rebars and reduce the spacing so that the quantity of bars that are needed will be ones that can be accommodated by the length and width of your pad footing. And in order to do that, you can change here to 175. And then you can also change this to 175. And you can see that now you have 10. And why you have 10 as 175, it also really means that you won't be able to remove your cover, which is 40 here, 40 here, 40 here, 40 here. If we have 200 spacing, so we can make this 200 spacing so that we'll have something like 9. And then you see that you have 9 here, 9y12, 9y12. And you still be able to remove your cover comfortably with your 200 spacing. And you can see that it's still okay. The design is successful. To just wrap this up, I would like to just kind of explain how pad foundation works. Pad foundation works by optimizing the bearing capacity of the soil. Initially, bearing capacity is 120 kilonewton per meter square, and now here we have 168 kilonewton per meter square. And what the footing does is that it helps to distribute the load on the soil in a way that the initial bearing capacity of the soil is now optimized, which means what used to be 120 can now accommodate something which is much more, and in this case it is 168 kilonewton per meter squared. So now you have this 168 kilonewton per meter square being the optimization factor of what used to be 120 kilonewton per meter square. And this is because when the load comes upon the pad footing distributes it in such a way that the stress on the soil is not acting in a way that overcomes the bearing capacity of the soil, and the ability of the soil to accommodate the stress to increase from 120 kilonewton per meter square to 168 kilonewton per meter square. Whatever we are now having as design needs to now fall below this 168 kilonewton per meter square, and that's why you have this right here that it's saying that it's okay because what we have designed is effectively transferring 152.39 kilonewton per meter square, which ordinarily the soil will not be able to bear. But because of our design, the soil will be able to bear it because the soil has been optimized from 120 kilonewton per meter squared to 168 kilonewton per meter squared. Don't forget to subscribe to our channel for more videos like this and hit your notification bell to be first to see our latest videos. Thanks for watching and bye for now.